All right, the lesson today is angle proofs. It starts out with a reference sheet that we'll kind of go through at first, and then we'll jump into some of the new definitions, postulates, or theorems next page, and then we'll knock out the proofs. Here we go. Up top, these are your properties of equality. Remember, these can all be used with equal signs. Properties of congruence. These are used when you're measuring a distance. And here are some new definitions, and some that repeat, but these are pertinent to the angles. Okay, first one. Definition of congruence. Once again, they just go from equal sign to congruent sign and vice versa. Definition of an angle bisector. It's simple, guys. You just cut an angle in half. All right. Cutting the angle right in half for angle bisector. Definition of complementary angles. Underline the word definition. And then what you need to know for this one, guys, is that it's a sum of angles that add up to 90 degrees. Definition of supplementary angles. For supplementary, the sum has to add up to 180. So definitions add up to a certain degree. If it's complementary, it's 90. If it's supplementary, it's 180. You need to know that. Definition of perpendicular. It's real simple, a visual for you guys. If I were to give you a coordinate plane, it just forms 4 right angles. Perpendicular lines form 4 right angles. That's all that is. And remember, right angles are 90 degrees. Definition of a right angle, it's simply just equal to 90 degrees. So definition of a right angle, it's an angle that equals 90 degrees. Postulate, this one should look familiar. Angle addition postulate is similar to segment addition postulate, except this case you take small angle plus small angle equals the big angle. Small plus small equals big angle. Just like your segment addition, small segment plus small segment equals big segment. Couple theorems. Gotta know the vocab. The vertical angles theorem. If 2 angles are vertical, then they are congruent. And we already knew that from chapter 1 where vertical angles are congruent. They're across from each other and congruent. Complement theorem. Underline the word theorem for me. If 2 angles form a right angle, then they're complementary. And I would underline this, guys. For the complement theorem, you need to know that right angles are complementary. Supplement theorem, I would underline the word theorem. If 2 angles form a linear pair, then they are supplementary. You need to know that linear pairs are supplementary. Complement theorem, right angles are complementary. Supplement theorem, linear pairs are supplementary. You need to know the difference between these two and these two. Definition versus the theorem, you need to know the difference. Congruent complements theorem. If A complements B and C complements B, then I can say A is congruent to C. A is the same measurement as C when it's complementary to the same angle. Same thing for congruent supplements theorem. If A is supplementary to B and C is supplementary to B, then A has to be the same as C because these angles are supplementary to the same angle, which would only mean that these guys would have to be the same exact measurements. All right, let's test out the new words now. All right, it says justify each of the following statements using a definition, theorem, or postulate. All right, one says A is a right angle, then A has to equal 90 degrees. That's your definition of right angle. And I was going to abbreviate, guys. Definition of right angle. Number 2, just talked about it. If X is supplementary to Y and X is supplementary to Z, then Y has to be the same as Z. Congruent supplements theorem. Abbreviate congruent supplements theorem. If these 2 angles are supplementary to the same angle, which is X, then these guys have to be congruent to each other, same measurement. Number 3, just look at the picture. What types of angles are these? The vertical angles. And it says 1 is congruent to 2, vertical angles theorem. Number 4, if the measure of angle P plus the measure of angle Q are 90, then they are complementary. What do we think here for number 4? This would be your definition of complementary angles. Remember, they have to add up to 90 in complementary. That is your definition. Definition adds up to 90. Number 5, if angle M and angle N form a right angle, then they are complementary. But here's the difference. They're complementary and form right angles. That is your theorem, complementary theorem. You need to know the difference between these two, guys. If they're complementary and add up to 90, that's your definition. If they're complementary and make a right angle, that's your complementary theorem. Notice the difference. Number 6, check out the picture. You have perpendicular lines right here, right? This missing a symbol right here. It should be perpendicular. The upside down T is your symbol for perpendicular. All right. Definition of perpendicular. We will not use that one very often. Number 7, W and X are supplementary. And if you add it up, it equals 180. If it adds up to a degree, that is your definition. Definition of what? Definition of supplementary. Definition of supplementary angles. Number 8. If L is complementary to M and N is complementary to M, then L has to be congruent to N. Complementary, and these guys are equal to each other. They're complementary to the same angle, which is angle M. That is your congruent complements theorem. Number 9, if A and B form a linear pair, then A and B are supplementary. Remember, just like up top, if right angle is complementary, that's your complementary theorem. Well, if it makes a linear pair and supplementary, that is your supplement theorem. Number 10, if N and P are complementary, then they have to equal to 90. We just use that one up top. That's your definition of complementary again. Number 11, small angle plus small angle equals big angle. That's your angle addition postulate. And last one, they went from equal sign to congruent sign. We already talked about that in the segments. Definition of congruence. This next page, guys, these are just all of the answers for the proofs for numbers 1 through 6. I gave it to you so you can kind of just go through it if you want to on your own for the notes. But put that aside. Let's go on to the proofs. Angle proofs. You might want to have a couple colors of pen here because once again, we're going to see that transitive property, and I like to number it with the green one to show you how I get that answer each time. All right, got one given. PQR is a right angle, and that's what I got to prove, right? PQR is a right angle. That was given to us. First reason is always given. Number 2, so how do we go from line 1 to 2? Well, if it's a right angle, it has to equal 90. That's your definition of right angle. Right angle to 90. 2 to 3. Angle PQS, this guy right here, plus angle SQR right here, equals a whole thing. Small piece plus small piece equals big piece. Angle addition postulate. And once again, I'm just abbreviating. Angle addition postulate. Number 4, it's good old transitive property. Let's number it. Line 2, I'll call 90 the 1. PQR is my 2. PQR is still a 2. This addition stuff is a 3. The addition stuff is still a 3. 90 is my 1. If 1 equals 2 and 2 equals 3, then I can say 1 equals 3, transitive property. Okay, 4 to 5. It says the angles add up to 90 and they're complementary. That is your definition of complementary. If they are complementary and add up to 90, that is your definition of complementary angles. Number 2, we have 2 givens. First one, angle 2 is congruent to angle 3. That's given. Let's fill in the other one. 1 and 2 form a linear pair. That's number 3. The freebies are all gone now. Write the proof. Number 1 to 2. Congruent sign to equal sign. Definition of congruence. 4 to 5. 1 and 2 form a linear pair, and they're supplementary. Ask yourself, is that the definition or is that the theorem? That is the theorem. If they do not equal a degree, it's always going to be the theorem of supplementary or complementary. In this case, it's your supplementary theorem. Number 5. Now I'm going from line 4 to 5. Okay. 1 and 2 are supplementary. 1 and 2 add up to 180. Well, they're supplementary and they add up to 180. That is your definition of supplementary angles. Okay, line 5 to 6. What's different here? It looks like they replaced angle 2 with angle 3, right? Check it out. Angle 2 is equal to angle 3. So I'm going to replace angle 2 with angle 3. Substitution. Whenever we replace or simplify, that's our substitution property. Line 6 to 7. These 2 angles add up to 180 and they're supplementary. Well, if they add up to 180 and they're supplementary, that is your definition. In this case of supplementary angles. Make sure you know the difference between the theorems and the definitions. You got to know the difference. Number 3, I have 2 givens. Let's fill them in. 1 and 2 form a right angle. Given. 1 and 3 add up to 90. That's also given. Okay. Line 1 to 2. 1 and 2 form a right angle. 1 and 2 are complementary. That is your complement theorem. Right angle and complementary theorem. Line 3 to 4. They add up to 90 and are complementary. If they add up to a degree, that is your definition. Definition of complementary angles. Number 5, kind of tricky. Angle 2 is congruent to angle 3. Well, check this out. It says 1 and 2 are complementary. 1 and 3 are complementary. That means that if angle 2 and angle 3 are complementary to the same angle, that means these guys have to be the same exact measurements. That's the last one we talked about on the new page. This is your congruent complement theorem. If these guys are complementary to the same angle, then they must be congruent. Congruent complement theorem. Number 4, we have 2 givens. BE bisects angle ABD. Remember, we're going to cut that angle in half. Bisect means to cut in half. So that was given to us. And the other given, BD bisects another angle. That's also given to us. All right, let's check this out now. Picture BE, ray BE right here, bisects angle ABD, which means this angle is congruent to that angle. And number 2 says that, hey, this angle right here, angle ABE, is congruent to angle EBD. What do? We bisected the angle. That is your definition of angle bisector. Number 3, BD bisected angle EBC. So this angle is congruent to that angle. So basically all 3 of these are the same exact measurement. Once again, number 4, same thing. This angle is congruent to that guy by your definition of angle bisector. All right, number 5, how the heck did they get that? Well, it's transitive property. Let's go back up through the proof. Let's number it. On line 2, let's call ABE the 1, EBD is the 2. Line 4, EBD is still the 2, DBC is a 3, ABE is your 1, DBC is your 3. If 1 equals 2 and 2 equals 3, then 1 equals 3, transitive property. Number 5, we only have 1 given. The rest of it we got to do on our own here. All right, line 1 to 2, congruent sign to equal sign, definition of congruence. Number 3, now this might be angle postulate, but I need to check it out. Is it angle addition? Let's look at it. Angle RSU plus angle SUV, that does equal angle RSV. So this angle plus that angle equals the big one. That is angle addition postulate. Angle addition postulate. 4, well, what maybe is this angle addition postulate again? Let's check it out. Angle VST plus angle USV. Does that equal angle UST? Sure does. That angle plus that angle equals the whole thing. So same reason for number 4. Number 5. Okay, what's going on here? Well, I know one thing. The only thing that is different from line 4 to 5, they just replaced VST with RSU. And yes, that is legal move. Look at this. VST is equal to RSU, so I just replaced right here. Substitution property. Number 6, transitive property. And once again, I will show you how I got that. Line 3, let's call RSV the 1. The addition stuff number 2. Line 5, the addition stuff is still a 2. UST is now my 3. RSV is still the 1. And UST is my 3. If 1 equals 2 and 2 equals 3, then 1 equals 3, transitive property. And the last thing, they just went from equal sign to congruent sign, definition of congruence. Number 6, we have 2 givens. Let's fill them in. Hey, it's both these right here. Both those are given to us. Easy money. All right, here we go. 3 says, hey, 1 and 2 form a 90-degree angle. Well, check this out. If 1 and 2 are complementary and they add up to 90, is that the definition or is that the theorem? Well, if they add to a certain degree, that is your definition. So this is definition of complementary angles. 3 and 4, same thing, right? If 3 and 4 are complementary and they add up to 90, same exact reason. Definition of complementary angles. Okay, number 5. Angle 2 is congruent to angle 3. Well, I'll tell you what. This doesn't help me at all right here. So I'm going to look at my diagram. If I check it out, there's angle 2, there's angle 3. Those are vertical angles. Vertical angles theorem. That's why they are congruent. They're across from each other and congruent. Vertical angles theorem. 5 to 6, they went from congruent sign to equal sign. Definition of congruence. Line 7. Line 7 is transitive property. And once again, I will number it to show you where it comes from. All right. Let's call Angle 1 plus angle 2 to the 1. 90 will be my 2. Next line down, 90 is my 2. 3 plus 4 will be my 3. Skip down to line 7. Angle 1 plus 2 is my 1. Angle 3 plus angle 4 is my 3. If 1 equals 2 and 2 equals 3, then I can say 1 equals 3, transitive property. All right, from line 7 to line 8. That's the same, that's the same, that's the same. This is not the same. They replaced angle 2 with angle 3, right? We said that. Angle 2 equals angle 3. They replaced it. Substitution property. Number 9. Okay, from line 8 to line 9. What's going on here? What did they get rid of on both sides? Well, the angle 3's are missing, right? They subtracted angle 3 from both sides to get here. So this would be your subtraction property. I subtracted angle 3 from both sides. And last step, equal sign to congruent sign, definition of congruence. Number 7. We have 2 givens. First guy is always given. And where's the other one at? 4 and 5 from a linear pair. That's number 4. All right, now we got to go to work. From line 1 to 2, your clue is definition of congruence. Well, that just means to go from congruent sign to equal sign. So angle 1 equals angle 4. Oh, I made a mistake on number 4. That's not given. Sorry. My given's right here, right? Angles 4 and 5 form a linear pair. Angle 4 and angle 5 form linear pair. Okay, now we're back on track. From line 3 to 4, they form a linear pair and they're supplementary. Is that the definition or is that the theorem? If they form a linear pair and supplementary, that is your theorem. What kind of theorem? Supplement theorem. Okay, the clue for line 5 is definition. Remember, definitions have to add to a degree. Well, what degree in this case? Well, we're talking about supplementary, so it must be 180. So angle 4 plus angle 5 have to equal 180. Supplementary, add up to 180, that's your definition. Okay, line 5 to 6 says, hey, substitution. Well, what do I know what's equal to each other? Well, if I look up top, I know that angle 1 is equal to angle 4. So I'm going to replace angle 4 with angle 1. So angle 1 plus angle 5 equals 180. Substitution. Okay, last reason. Angles 1 and 5 add up to 180. And they're supplementary. If they add up to a degree, that is your definition. Definition of supplementary angles. Number 8, we have 1 given, 2 givens. 1, 2 form a linear pair. That was given. All right, I'll be smart this time. My other given is number 3, right? Measure of angle 2 plus measure of angle 3 equals 180. All right, line 1 to 2. Clue is supplementary theorem, right? Remember the theorem, linear pair, and they would have to say that they are supplementary. So linear pair and supplementary to get the theorem. So I need to say angle 1 and angle 2 are supplementary. Remember, guys, form a linear pair and supplementary. That's your theorem. See, line 3 to 4. Clue is definition. Definition means they have to add up to 180 and be supplementary. So now I just got to say that, hey, these two guys are supplementary. So angle 2 and angle 3 are supplementary. Once again, if they add up to 180 and they're supplementary, that's your definition. 1 and 3 are congruent. What the heck? We got this. If 1 and 2 are supplementary and 2 and 3 are supplementary, that means these two guys have to be congruent because they are supplementary to the same angle. That is your congruent supplements theorem. Number 9. Number 9, we have 1 given, 2 givens. This should be a perpendicular sign right there in the given, guys. So number 1, 2, that should be perpendicular. All right, let's fill in the givens. 1 is given to us, and the other one, angle 2 and 3 are complementary. Angle 2 and 3 are, whoa, way down here. Number 7. Angle 2 and angle 3 are complementary. All right, let's go to work. It says AB is perpendicular to BC. Then I can say that ABC forms a right angle. Well, if they're perpendicular and forms a right angle, that's the one that I say we didn't talk about a whole lot. That's your definition of perpendicular, just abbreviating. If these guys are perpendicular and they form a right angle, definition of perpendicular. All right, definition of right angle. Well, I got to define what that is, right? Line 2 says, hey, ABC is a right angle. Then the measure, M stands for measure of angle ABC has to equal 90 degrees. Definition of a right angle. It's a right angle that equals 90 degrees. Definition of right angle. All right. I'm thinking angle addition, but I got to check out the diagram to make sure that these two angles add up to angle ABC. All right. Angle 1 plus angle 3. Does that equal angle ABC? Yeah. This angle plus that angle equals the big thing. Angle addition postulate. Okay, number 5. It is transitive property. And once again, I will show you how I got that. Let's call the 90 a 1. Measure ABC at 2. Measure ABC at 2. The addition stuff is a 3. Addition stuff is a 3. 90 is the 1. If 1 equals 2 and 2 equals 3, then 1 has to equal 3. Transitive property. All right, from line 5 to 6, the clue is definition of complementary. Well, I said they're 90. Now I just got to say that they're complementary. So I'd say angle 1 and angle 3 are complementary. Okay, check this out. Line 7 to 8. Okay, it says angle 1 is congruent to angle 2. Well, check it out. If 1 and 3 are complementary, and 2 and 3 are complementary, then I know that these guys are congruent to each other because they are complementary to the same angle. This is your congruent complements theorem. That's it for angle proofs.